Welcome to this talk about Ethereum. Меня зовут Nicolas Frankel. Мой русский очень плохой. Но я могу говорить чуть-чуть. So I will switch either to English or French. Which is better for you? French. Guys, do you have 1 hour to sleep just after lunch? So better make it in English, I think. So I'm a developer. I'm a Java developer, actually. That's how I pay my bill. I work for a little startup called SAP. Perhaps you know about it. And there I work on the e-commerce platform called Hybris. So basically I'm helping customers integrate Hybris into the information system. And at night I do like very interesting stuff like blogging and preparing my talks and stuff like that. Something very important. I'm a developer, really, I'm a developer. I'm not a fintech expert. I'm not a fintech expert. I'm not a blockchain expert, and I'm not an Ethereum expert. This is just what I learned by myself, because it's very hard. I mean, the documentation is quite fragmented right now. It's just what I learned that I want to share, so that you can start developing on the blockchain, on the Ethereum blockchain. Something very important, just attending the presentation won't make you rich. Sorry about that. If you attended this presentation thinking that I would give my ethers or my bitcoins away, just no. You can go, there is still time, you can find another slot, but here not. So the first question is, of course, what is a blockchain? And the answer is pretty stupid. Now you are expert as well. It's a chain of blocks, and it is like designed like this. You have the first block, which is like the foundation, and every time you can add a block on top of it, and every block has a content and references its parent block. So you pile stuff upon stuff upon stuff upon stuff. And who here already uses Git? Yeah, nearly everyone, if not everyone. I mean, not counting the people who are sleeping. If you don't do rebase, if you don't do branching, if you don't do merge, if you just have master, you can consider Git as a sort of blockchain. Now, every commit references its parent commit. So if there is no rebase, no nothing, there is only one single parent, and then you pile it one atop the other. So the concept of blockchain itself is pretty stupid. Now, if we add like properties given by the blockchain, there are several properties that are very interesting. The first is it's immutable. Like when you do Git, normally you can like rebase stuff and a reflog and do a lot of crappy stuff. But imagine you cannot do it. And by the way, it's advised that, for example, instead of removing one commit, you just like do the opposite commit. Here it's the same. So once you've done something of the blockchain, when you've passed a transaction, it's written there for eternity. So you cannot cheat, you cannot lie, you cannot not go back. The only thing that you can do is execute another transaction that is the complete opposite of the one you want to cancel. The second one is that it's distributed. It's, of course, dependent on the technology, but basically you can consider that every computer that run one specific blockchain has the entire copy of the blockchain on the system itself. So it's like the ultimate distributed database where every node contains the whole stuff. And the final property is that it's transparent, meaning that, of course, I'm talking about like public blockchains. Anybody can look at it and checks who did what. Congrats, now you are blockchain experts. And it's very interesting that one of the most used technology on top of blockchain is cryptocurrencies. Money, dollars, Who here has Bitcoins? Quite a sizable, like 20%. Ethers as well, the same guys. Okay. Okay, I will tell you something very controversial. I believe this is bullshit. This is crap. This is not interesting at all. Basically, you're just like trying to get money out of money. That's my opinion. I'm trying to do like perhaps sometimes more meaningful stuff. And on Bitcoin, for example, the only thing you can do on the Bitcoin blockchain is you buy Bitcoin, and I mean, not even on the blockchain itself, but you can set Bitcoin to another account. Or you can receive Bitcoins. I mean, as a developer, that's not very useful. And there are several ones that are like valued by I don't know who. I don't know how it's computed. I mean, it's probably you who give them value because you buy them. But basically, you are buying bits. So if tomorrow nobody gives value to that, your bits are worth 0. Yeah, frightful thought. Huh? Sorry about the 20% of the room who have this kind of stuff. But again, I'm willing to be proven wrong. However, Ethereum is very interesting in all that stuff. Because on Ethereum, you can actually write code. I mean, how cool is that? You can write code on the blockchain, not just get money out of it. You can write your own code. And afterwards, of course, you can deploy it on the blockchain. And guess what? You can call it outside of the blockchain also. Those called like distributed apps, dApps, if you have come upon the term. And I think that's, if you are a developer, is much more interesting than just like giving and receiving money. That is something you should never do, like write a big block of text into your slides. But because I'm French, so I'm super lazy, I will just let you read it, because it's written in, I think it's written in a way that even I could understand. So basically what it tells you is that Ethereum, it's not only like state, but there is a virtual machine involved. And if you are Java developers, who here is a Java developer? Half the room. Okay? Who here is a .NET developer? So half of the other half of the room. Who here is a JavaScript developer? Okay, a few hands. Okay, so there are a lot of people doing real stuff. Code of conduct, sorry. On the Ethereum VM, basically you have two types of accounts. The first type is, of course, like you go to a bank, you open an account, this is your account, this is the exact same stuff. There is one guy behind the account. But the other type is very interesting. It's called like a contract. And perhaps you have stumbled upon the term smart contract. Interestingly enough, depending on the cryptocurrency technology, the smart contract doesn't tell you anything. It has different meanings. But on the Ethereum blockchain, smart contracts mean code. So actually, code on the Ethereum blockchain can have money, can have ether. I will come back to it later. And some very important concept on Ethereum is this. Basically, nothing happens. If you don't do anything, nothing happens. And when you start doing transactions, sending ether from one account to another, well, if it's an account owned by someone, that's not very interesting. But if you send money, ether, to code, then the code will start doing stuff. And if you think about it, it's very similar to a database in that regard. So basically, the database, if you don't do anything about it, it just lays like, does nothing. Then you send requests, and you can execute stored procedures. And stored procedure is just code that is stored in the database itself. So I think there is a nice parallel to make between the Ethereum blockchain and stored procedures and databases. With the difference that, again, every node on the blockchain has the same stored procedure, has the same code. So how do we start? Ethereum runs specific bytecode, so not Java bytecode, not .NET bytecode. It runs really, really specific bytecodes that you can produce with different languages, but the language of choice, the language that is like recommended, is called Solidity. Anyone here heard about Solidity already? Yeah, a couple of hands, great. And so the good thing about Solidity, at least from my point of view, is that it's statically typed. So I don't need to infer the type of stuff or to write tests because to avoid like casting mistakes. You can have inheritance. There is a limited formal library, but very limited so far. And you can create your own types. So basically, with inheritance and creating your own types, you start thinking about how I can perhaps do like object-oriented programming. Well, limitedly, yes, but not very nicely. So I think it's time for me to make a demo because I see some people starting to sleep already. That's a good thing about being in a movie theater, but it's sometimes not that great. Okay, so here I open a stuff called Remix, and Remix is an online IDE so that you can start without installing anything. You just want to hack your next startup ID, you can start just right here. This is one of the stupidest contracts you can write. So the first line is actually mandatory. It tells you about which version of the language you are using, so you can like keep it up to date with the latest version, or you want to be backward compatible or whatever, so you tell the version first. If you are a Java or even a .NET programmer, you see that instead of a class, you have the concept of the contract. So it's like mapping one-on-one. They just want to use one fancy word. And then you've got this function stuff. So the visibility modifier is after the signature. And you see that the returns, there is like a really keyword, returns, to tell you what stuff it returns. Some differences that I think are quite interesting. The first thing is you can name your return value. That's super useful. I mean, I don't know if sometimes you would have liked to name your stuff in Java or .NET, but naming a return value is always a good idea if the language allows you to, because documentation is, like, unfortunately never enough. What we can do also is we can return tuples. So I will say A, B, and BB because I cannot use the same. I cannot use the same name because it's already part of the signature. So I will return it like that, and I will return A and B, for example. This is the kind of stuff that I can do. I mean, so far, everybody understands the code. Huh? That's nothing mind-blowing. Yeah? A plus B. But still, the stuff seems to like warn me about something. And who here does like functional programming? Okay, a few hands. I thought there would be more. Who can tell me what's specific about this function? I can even make it simpler. What's specific about this function? Nobody? Or still sleeping? Hey, the functional programmers here.
No side effects.
No side effects. So, thank you. This is considered like a pure function, like a really pure, because basically the return value is only dependent on the arguments. So we can tell it to the compiler. And now it's green. So basically I have to tell the compiler, hey, I have no side effect, although he knew about it before, but there is still a keyword that lets you really tell that there is no side effect, and that basically you don't read nor write anything. And on the blockchain, that is very, very important. The most important the most important difference that you understand about the blockchain is that by writing states on the blockchain, you are like modifying the state, you are updating the state. And if you have done Bitcoin, if you have done Ethereum, anything, you know that by changing the state, basically someone must execute a transaction for that. And in general, you delegate this role to like miners. The people who are like changing the states, they are miners. And it takes them time and CPU, so energy. So the most important difference is that every time you write on the blockchain, on the Ethereum blockchain, you have to pay. Not a big amount, but a small amount. So compared to traditional Java, .NET, or whatever code, whenever you want to write, you think about it before, think, do I need to write or not? Hence, you have two important keywords, like pure, we don't read, we don't write, and I think it's read-only, meaning you don't write, you just read from the blockchain, which is free. No questions? I will take that as a no. So again, you have a language version header, contract instead of class, the return value can, and in my opinion, should be named, multiple return value, and a pure keyword, plus the read-only keyword. Good. You're good to go. Now you can start. No, you cannot. You really are super sleepy. I don't know what I should do. Like perhaps, should I speak in Russian more? Как Uzbek? Are there any Uzbek people in the room? So, sorry about that. I'm sorry. That's always the stupid joke, and I'm always like praying there is no one because, yeah, sorry, I apologize. Now you are not sleepy anymore at all. What I showed you before, the people among you might have noticed that I was in a browser, so I didn't do anything. I didn't deploy the contract, I didn't even run the contract, I did nothing. So the next step is, of course, you want to like do it for real, because you want to like do integration testing probably, and before doing integration testing, you want to deploy the damn code, and you want afterwards to test it. And though there are several ways to do that, you can have your own private blockchain on your computer. Yeah, it's possible. Crazy, right? Or you can deploy on a test network, a shared test environment shared by everyone. Or you can even afterwards, if everything is fine, like deploy to production. So how does it work? So first, what I want to do is I want to run inside the JavaScript virtual machine. So it's like an emulation environment. So I have this compiled code. So I'm auto-compiling. So since it's green, I can deploy. Here it tells me that he recognized there is this mathematic contract, and I can deploy it. So I will remove that one. That was my previous one. And now it's deployed. One click, it deploys. And now I can call the add method and passing its parameter. And it works. And again, here you can see that it gave me the return value with a name, which is, again, always nice. And just to make sure that I'm not fooling you, I will like put again my previous code and return many different parameters. I can deploy again this one, and this one is a new one. So I free 3, and 4, and so it gives me the sum plus A and B. So I can play with that, but it's not that great. So to deploy for real, what we can do is we can use something called the Ethereum wallet. I will quit it because I want it. Oh, perhaps I shouldn't have done that. Yes. I will launch it again, and sometimes it takes a bit of time between the last transaction. So now it checks the network, and perhaps I'm dead now. Yes, it started. And basically what I want you to see is if it's able to sync. Yeah, so now it tries to sync between the state that is like the overall state and the state of my machine. And now I am, no, it was super quick because of course I just quit right now, so not many transactions were paused. What I can do now is I can try to deploy my super nice contracts on the blockchain. So I open the contract view. It's big enough for everyone to see? Yes, okay. And so I can like paste this like super nice contract. Here you can check the bytecode or not yet. Here I can check the contract. And now, again, it asks me how much Ether, like how much money I want to spend to deploy it. Because again, I am writing on the state of the blockchain because the contract, like it states, I'm changing the state of the blockchain. So of course, I can spend as less as I want or as much as I want, and the less you spend, the law of offer and demand, the slowest it will be, and if I want to spend really a lot, I can be super fast. So I hope by spending a lot of money, I can get something. So now I've got stuff, and very important, now I'm playing not for real, so I need to give my password. That you don't see my password. Oh no, you don't see my password, but it's a wrong password, so that's normal. What should I do? Uh-oh. Now I'm in deep trouble. So if you give me 5 minutes, yeah, I know it's not that good, but since I don't have the right password, it's pisiec. And I know the real word, huh? But ja wieźli Francuz. Making joke is good when you are in deep trouble, huh? Stop. That's too much. Okay, Ethereum. So normally I should do that, and now I can back here, sending, no. What did you do? Okay, deploy new contracts, mathematic. No, I never said that. I don't know what happens now. Perhaps I'm not connected to the network. That is super uncomfortable. So what I will do now is like, suppose everything was fine. Yes, thanks. So I will go to contract again. So those are the previous one that were deployed. And here you can see that I still have the A and B stuff. So I can like say 5 and 4 or 5. I say 4 and 5, and this is my code deployed on the blockchain and code executed on the blockchain. How cool is that? Yeah, thank you. You should applaud not for the demo, but my coolness under pressure when demo doesn't work at all. Okay, that's good, but probably what is the next step? A production network u меня нет денег. No, the thing is, if you are developers, the next step would be like to do some testing and not only like click, deploy, click, 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 but to do some real integration testing, like automated testing. Yes? It will be super nice if you answered yes, because otherwise I'm in deep trouble. Thanks. It's your first conference, right? Okay, so what you can do is you can use something called truffle. And truffle is a kind of, sorry, I was a bit slow. Truffle is like a framework for the blockchain. Like if you do Java, you have no clue how you can test your Java code. You have to understand about building your code with Maven, for example. You must understand about JUnit or TestNG or whatever. So Ethereum doesn't come with its own stuff. So you should have something called truffle. And sorry for Java developers, for .NET developers, sorry for the word, it's an NPM package. You have to install Node on your machine.
I'm great.
Who said that? So, and truffle gives you everything out of the box. So it even provides you with a way to manage your migration. So migration is basically a deployment so that you can know in which state you are and then only like do the gap, what is missing. Because if you like deployed already 3-4 times on the network and you need to just add a gap, like deploy perhaps a new bit of code, you don't want to redeploy everything because it will cost you money. So you just want to deploy the gap. So let's do that. So here, I assume I already installed Truffle. What I can do is I can show you my beta code. So here what I want to do is I want to create a voting contract. So it's a stupid use case because, as I said previously, one of the properties of the blockchain is that it's transparent, so everybody will know what you voted, which basically you don't want. But let's imagine that it's a super good idea, like make your vote public. I need two things. I need like a token that I will give to people. It's like, you know, your vote, and a way to handle the vote itself. So I want people to be able to vote. So first I will create the token, I will distribute the token to people, and then afterwards the people with the token, they can spend it to vote. It's an interesting abstraction. So this is my voting token. As you can see, I have like a symbol. I can create different kind of tokens, so I need a label. I can have a total supply, the number of votes that I'm distributing among the people. Perhaps some people, I will give them more because they gave me money, I don't know. Or because I like them, or because they are my brother-in-law, I don't know. And here is like a hash map of the address and a uint 256, which basically is the address of your wallet. I think that's an interesting point, so let me talk about it for some minutes. In your mind, you have an account, and you have different kind of currencies in your account. Well, you have different accounts for every currency, but you have like an account for euros, and then you have a sum. And then you have an account for, I don't know, ruble, and then you have a sum, this kind of stuff. In your mind, you have all that. Here, the interesting stuff is that the ownership is on the token side, on the currency side. So basically, it's the currency itself which knows which owners it has. That's interesting. And here, so the address of the contract and the amount. And to create a voting token, I will need the symbol, I will need the total supply, and I will also be able to transfer, and I will also be able to burn, because at some point I want people to be able to say, okay, I voted, so I will like burn the stuff. So remove something from existence. And because I cannot use my wallet, I will just want to show you here. So this is the same. This is the same code. And I can try to deploy it. So here, let's say I want to deploy, I will remove the previous one. I want to deploy a voting token, so let's call it, are there any English people in the room? No, okay. So I will call it Brexit. It's not in the code of conduct. And I can say, okay, I will give like 20 votes for everyone to vote on that. And you can see here that I can like read from the stuff. So what is the symbol? It's called Brexit. What is the total supply? It's 20. And then I can try to like burn some of them to check how it works. So I will need my own account address. So my own account address is that. Oh, sorry. And I can say I will like burn 5. And then I can check that normally it should be 15. Please work. Yes. I love a demo when it works, and not when it doesn't work. So, of course, you can do the same. You have the referendum contract, and the referendum contract. Again, you can have So it has the address of a referendum, and it knows all the token addresses. So let's I want to deploy this referendum contract now. I need the questions. So. Do you want to leave EU? I think it's 1 because it's the limit, the number of votes you want to do it, and it takes as an argument the address of the previously deployed contract, which is the voting token. So normally here I should deploy it, and I have my stuff. And now I can say, okay, what is the questions? How do you want to leave EU? What are the results? Well, so far there is no yes count, no count, and no black count. And there is open, I mean, this kind of stuff. And then afterwards you can close the vote, get the number. I mean, this is not really important. The point is you can do everything inside this remix stuff. And afterwards you can do it in Truffle. So let's see how it works in Truffle. I've got this referendum stuff. So normally if I do that, you should have zooming. Where is zoom, please? Zoom, yes. So you have the APIs of your contracts which are generated automatically. Here is your code, sol is for solidity, and this is the code that I showed you. Here are the migrations. So by default, you will have this initial migration and migration solidity, and that's how it keeps track on your deployment. I told you that you just want to deploy the gap. Basically, the state of your deployment is written in the blockchain. So deploying costs you 2 times just because you need to change the state of the deployment, plus you need to deploy. And afterwards, you've got your own code here. So this is how you deploy. I will show you the code afterwards, and here is the tests. So let me back to this. And for example, I told you this is the migration. So again, I'm sorry, it's JavaScript. And here you can say that I create the voting token, which I call token. and I pass the arguments that are necessary. So I create a token with a label and a quantity. And because of one, the contract references the other, because only people who have this Brexit token can vote about leaving the EU or not, I need to pass the reference. And that's using like a simple callback in JavaScript. That's super easy if you have this kind of stuff. So you can create contracts that depend upon contract, that depend upon contract, and you don't need to know the address of the first one. You can automate everything. As for the tests, well, if you have been doing any kind of Karma or I don't know which JavaScript testing framework you use, you can see here it's like quite assertive. You have this it plus label, and then you've got an async function because you don't know when you will get the result. And then afterwards, you can write your code and check whatever you want. So how do I do that? Now I am using Truffle. So first, I want to try it on my local machine. I want to try it on my private own blockchain. So I can, like, say, Truffle develop. Whoop. And now it created my own private blockchain, and I can test it. So it does everything that a build tool is supposed to do. It compiles, it deploys, and then it runs the test. And it works pretty well so far. So afterwards, there is this Truffle, I don't remember the name, but I want to deploy on Rinkerby. So I want to deploy on the test network, the one that didn't work with my wallet because I forgot the password. So I won't do it now because the password is already lost. Interestingly enough, I can tell you about the results, and the results is it won't work. Any idea why it won't work if I do the same on a Rinkerby? Exactly. I didn't provide the way to give money to my contract. So basically, when they will try to execute the test that change the state of the blockchain, they won't have enough money because they have nothing, and then it will fail. So that's very important, really, to think about that every time you need to change the state of the blockchain, it costs you money. So as a developer, of course, you want to minimize the amount of money that is spent, and even think about it when you are doing your test, then you need like this money stuff. How do you get money? Nobody asked me this question. How do you get money? Of course, on the production network, you have to pay with real stuff, real usable cash, dollars, euros, whatever. But on the test network, there is this faucet. Sorry, I never know how to pronounce this word, like many English words. Faucet. Okay, great. Even with my French accent, but it's great. So you ask the gods of the Rinkerby network to give you money. So basically, you either tweet or use Facebook or Google Plus with the with the address of your contract, where to send Ether to, and then you say, give me Ether. So you can ask for 3 Ethers every hour, you can ask for 7.5 Ethers every day, or for 3 days you get more. Of course, if you are in front of your computer, it's better to ask for every 8 hours because it gives you 9 Ether. So let's try it. You cannot automate it, so it's protected. So of course you need to say, hey, those are the vehicles. Oh, I was super bad. It asks me again. At some point, there should be like a nice message telling me, hey, you received that, or no, yes. So now I am like 3 Ethers, .5 or 3 Ethers richer. And normally, like, yes, it should appear in my wallet at some point, but I'm so rich that I don't care anymore. So this is how you get your funding for testing on the Recombine network. What is also interesting is I told you that everything is transparent on the Ethereum blockchain. So what you can do is you can search for the contracts that I deployed previously. So if of course it didn't work in that case, but let's imagine it worked. So we can search for the deployed contracts. Please let it work. Perhaps a bit slow. Yes. So here you see like everything. I don't understand how it can have so many transactions. I don't understand that, but it's not the right address because it's like nearly 1 year old. So perhaps, here. It was the address of my wallet, probably. Yes. So I created this contract like 20 days ago, and because, I mean, it cannot hold money, this one has no way to hold money, I mean, there is nothing else. And of course, so you see it has 0 value, and it can tell you where it came from, and this is the stuff, that is probably my wallet. Yes, this is my wallet. So it can tell you who deployed it. Of course, there is no name, it cannot be linked to your identity, I mean directly, but I mean they know you. Which is probably the end of my talk at this point. As always, you can read my blogs, you can follow me or ask me questions on Twitter. The referendum contract and the voting tokens you can find at this address if you want to check the code, how it's made, and yeah. On my blog also, I've written, this talk is about a summary of like 5 posts that I've written trying to understand how all this works. So if you want to go into the detail, you can also check my blog. Are there any questions at this point? Yes, there is one question.
Hi. Have you managed to do some real production contract? Or can you give some example of real production contract that really was useful?
Does that answer your question?
Example. Maybe you know.
Theory, I'm super bad at theory. No, I know an interesting example that it's in the gaming industry about trading cards. So basically, are there any like Magic the Gathering player or this kind of stuff? Yeah. Yeah, you. Okay, that's perfect. So basically, by like if you buy a card in any of those platforms, then you can perhaps, with some luck, like sell the card or like exchange the card with someone. But you are dependent on the platform itself. If the platform crashes, you are dead. I mean, it's like the bitcoins. Everything that you bought is for naught. What they did is basically they use the blockchain to give you the responsibility, to give you the power to handle your own cards. So every time you buy a card, it's a blockchain transaction. And basically, you can exchange your cards, not passing through the platform itself. So basically, they empower the users to do that themselves. And what they also do is they can reuse the cards between games. Of course, right now, they are only using the cards between their own games, but nothing prevents you from reusing them. And I think that was an interesting use case. And it's not about money, it's not about making the world better, it's just fun stuff. Other questions? Yes. No?
Does this code work internally, or it can call external API, some external services?
Sorry, could you please repeat? I'm not sure I understand.
Can this blockchain code call external services, external API?
That's okay. So does the blockchain, can the blockchain calls external API? No. Like, you can call it, and it can send events. So what you can do is you can register to events so that when something happens, you know about it. I can perhaps show the code. So that's how you interact with the blockchain. Basically, you subscribe to events. Again. So here you have this special syntax called like event. So basically it's a data structure. So you create the data structure, and afterwards you can, when something happens, like create an instance of this structure, and whoever subscribed to this event then can be notified. And generally you do it on JavaScript. So you can call the blockchain from the outside, and you can also like subscribe to events.
On my local machine.
But why your local machine? Because basically the blockchain on your local machine will be the same as the blockchain on my local machine. I mean, delta the time it takes to sync between our machines, because we run the same. That's the magic of the blockchain. Your state is the same as my state after some point, like eventually, because we will be eventually consistent. So you have the whole copy of the blockchain on your machine. I have the whole copy of the blockchain of my machine. I am the master of the blockchain because I have everything. Any more questions? So, is there a time for one more question? I asked the nice lady in front. So you have to do it very fast.
Is there a kind of UI for building environment to build UI for the contract?
Is there any environment to build UI for the contract? Well, you can do your UI in whatever you want. What you need is an API. I was cut. What you need is an API to call the blockchain. So basically you can do your stuff in JavaScript because you have a JavaScript API. I think that there is a Java API, there is a Go API, whatever you want. But they don't care. I mean, think about it like a database. You wouldn't ask me, hey, do I get an ID to the UI on a database? No, because you just have your SQL stuff, and what you do with the data afterwards is not your problem.